Okay, this is section 6.2, problem 3, the got it. Part A asks to find the values of x and y in the parallelogram. All the markings are on the diagonals, and what we know about the diagonals of a parallelogram is that they bisect each other, meaning that they divide into two congruent segments. So that means we know right off the bat that 3y minus 7 has to equal 2x, and that x plus 1 has to equal, hey, where'd you go? Well, for some reason it is not wanting to stay. Hold on. Okay, there we go. And x plus 1 is equal to y. Since we already have this set up as linear equations and we already have y solved for, we can substitute the x plus 1 in where y was in the first equation, equals 2x. Do the distribution, so 3x plus 3 minus 7 is equal to 2x. If we subtract the 3x from both sides, we end up with negative 4, 3 minus 7, equals negative x. So that if we divide by negative 1, then 4 is equal to x. Okay? And once we know the value of x, we can go back to the very beginning up here, and it doesn't matter which one we plug it into. So if we do x plus 1 equals y, and we know that x is now 4, then y must equal 5. Okay, so that answers the first part. The second part is to find the two diagonals. So PR, whether we do it into the 3y minus 7 or the 2x, remember that the two halves are the same. So if we do 2 times 2x, oops, sorry, not where I wanted to go. If we do 2 times 2x, and we know that x is 4, we get, let me go back here, this is PR we're doing. We could calculate both the 3y minus 7 and the 2x, but remember we already set them equal. So whatever 1 comes out to be, they better all be. And I missed a parenthesis, there we go. So 2 times 4 is 8, times 2 is 16. So PR is equal to 16. And then if we do the same thing for, I'm just going to make a little more room here. If we do the same thing for SQ, SQ is equal to 2y, or 2 times x plus 1, or x plus 1 plus y, doesn't really matter. We're going to get the same answer. So 2 times 5 is 10. So SQ is 10. Part B says, in problem 3, does it matter which variable you solve for first? If we think back to solving systems, the answer is no. You solve it either using substitution or elimination, and once you find one variable, you're going to find the other, so it doesn't really matter. So our explanation would be when solving systems, you can solve for whichever variable is easiest. It does not matter which one, because you just go back to the beginning, plug it in, and you find the other one. Okay?